Hello everyone, welcome to the ITLS Academy. Today we are going to discuss the topic that is your measurement of pH by our electrometric method. Okay, so first of all, we are going to discuss about the introduction of this pH. Okay, then after that we are going to discuss about the electrometric method. So pH is what? pH is the logarithm of reciprocal of hydrogen ion activity in moles per unit. This pH are simply defined as a logarithm of reciprocal of hydrogen ion activity. Simply. In water, solution variation in pH value from 7 are mainly due to the hydrolysis of salt of strong base and weak acid or vice versa. Okay, so if we take an example of water solution, so if it suppose that we take up this is the water solution. Now, if there is a variation of pH value from 7. Okay, so it is either due to the hydrolysis of salt of strong base and weak acid, or either from a salt of strong acid and weak base. Okay, now in that case, there is a gas are dissolved like your carbon dioxide, hydrogen sulfide, and ammonia. It will also affect the pH of the water. We already know that the normal pH of the water will be a 7, but if there is any dissolution of the carbon dioxide, hydrogen sulfide and ammonia occur, then it will also affect the pH of the water. Then the overall pH value are range from natural water is generally between 6 to 8. So we consider the overall pH value of the natural water are generally from 6 to 8. In case of alkaline thermal spring water, the pH value may be more than 9, while for a acidic thermal spring water, the pH value will be 4 or less than 4. Okay, if we take a alkaline thermal spring water, now in that case the pH value will be 9, but in case of acidic thermal spring water, in that case the pH value is 4 or even sometime less than 4. Industrial wastage may be strongly acidic or basic, and their effect on pH value of receiving water depend upon the buffering capacity of the water. The pH value of water are also obtained in a laboratory may not be the same as that of the time collection of the sample. Okay, it is not necessary that the pH of the collected water and when it reaches to the lab will be same. And why it happened? Because of there is a loss or absorption of the gases, reaction between the sediments, hydrolysis and oxidation and reduction taking place within a sample. The same sample water pH value should also use to determine at the time of the sorry, pH value will also uh, determine at the time of the collection, otherwise its value will be affected, and it will affected either by a loss or absorption of the gases, reaction of the sediments, and hydrolysis and oxidation or reduction taking place at the same time in the sample bottle. Now the next is your principle. The pH value is determined by measurement of the electromotive force of a cell, which consists of an indicator electrode which emerge into the test solution. Okay, so pH value is determined by measurement of the electromotive force of a cell, which consists an indicator of electrode, and this electrode, suppose that this is your electrode. Now this electrode are already immersed in a test solution. This is your electrode, and reference electrode. Now, contact between test solution and the reference electrode is usually achieved by means of liquid junction which form a part of the reference electrode. Electromotive force is measured with a pH meter, that is high impedance voltmeter, which are calibrated in terms of pH. Now, the next is your several types of electrodes have been suggested for the electrometric determination of the pH value. Okay, so there are lots of the electrodes are in the market which are suggested for measuring the pH value by electrometric method. Although the hydrogen gas electrode is recognized as a primary standard, the glass electrode in combination with a calomel electrode is generally used. Okay, so the glass electrode with the combination of the calomel electrodes are generally used with reference potential which provide by a saturated calomel electrode. The glass electrode system are totally based on the fact that if there is a change of 1 pH unit, then the product and electrical changes of 591 millivolt at 25 degrees Celsius. The active element of the glass electrode is a membrane of special glass. Okay, suppose that this is your glass electrode. Now the active membrane, or you can say that active element of this glass electrode is what? It is the membrane of special glass. The membrane form a partition between two liquid of differing hydrogen ion concentration and a potential which is used to produce between the two sides of the membrane, which is proportional to the difference in pH between the liquids. Now the next is your interference. So here there are different interference take place. This is your first interference and this is your second interference. Interference means that which interfere between the experiment and affect the result. The first one is that at pH value above 10, high sodium concentration interfere with the measurement. So the correction for the sodium error may be made by consulting the chart supply by a manufacturer of electrode being used. Okay, if there is a high value of pH that is around 10, then it means that there is a high concentration of the sodium effect and it will interfere the measurement. And for the correction of this sodium error, we have to take a chart which are supplied by a manufacturer of electrode and it is used. Then sodium error at pH value greater than 10 can be reduced or eliminated by using a low sodium error electrode. So in that case, what we have to do, we have to use a low sodium error electrode. Now, the next interference is that oil and grease may interfere by coating the pH electrode. Maybe the pH electrode are coated with either oil or grease, or maybe you take a measurement of some sample like some oil, and you will you didn't clean that oil, so that type of oil coating oil will also affect the pH of the pH electrode and they causing a sluggish response. This coating can usually be removed by gently wiping or detergent washing. So for removing this coating, what we have to do, we generally wipe it or wash it with the detergent, and followed by a distilled water rinsing and additional treatment with a hydrochloric acid 1% may be necessary, so that it will remove the remaining film. Now the next is your the next interference is temperature affect the pH value in two ways. Okay, temperature affect the pH value in two ways. The first is covered by the change in electrode output at various temperature. Okay, so the first is covered by we take a electrode and measure it at various temperature. This interference can be controlled with an instrumental having a temperature compensation or by calibrating the electrode instrument system at the temperature of the system. Okay, when we calibrate it, this problem will be resolved. The second source is the change of pH inherent in the sample at various temperature. This error is sample dependent and cannot be controlled. Okay, the next error is what? It is the sample dependent and it cannot be controlled. Therefore, the temperature at the time of analysis should be reported. Now, the next is your apparatus. So here we use a pH meter with a glass and reference electrode. Okay, so again, how we calibrate this pH meter. The video related to this topic are already uploaded in our account. You can go and check it. Here the because why I'm going, why I tell you this thing, the calibration part, because when we have to measure the pH of any sample, so first of all we have to calibrate it, then after that we have to measure it. That's why I told you the video related to this topic are already uploaded in our account. Now we required a pH meter along with a glass and a reference electrode, that and this reference electrode is what? It is a saturated calomel, preferably with a temperature compensation. Otherwise, it will affect the temperature. Now, magnetic stirrer with a polytetrafluoroethylene coated stirring bar. First instrument, second instrument, and the third instrument is your thermometer with least count of 0.5 degree Celsius. So we require three apparatus: pH meter, magnetic stirrer, and thermometer. Reagent. Now we required a some buffer solution, and how we prepare this buffer solution we will discuss in the next slide. Standard pH buffer solution we prepare using a commercially available tablet or powder with a NIST traceability or known amount of chemical. Now the procedure for the preparation of some standard pH buffer solution are given in the table below, and below means that in a next slide, and table 1 which shows the pH values of these buffer at a different temperature. So first of all we are going to discuss about how we prepare this buffer solution. How we prepare these buffer solution. Now after that we are going to discuss the table in which the pH value of these buffer at different, which shows the pH values of these buffer at different temperature. Now the first buffer solution is your borax buffer. So for this we required the solution of 0.01 molar, pH 9.18 and temperature 25 degrees Celsius. Okay, so the first solution that we have to prepare is 0.01 molar solution whose pH is 9.18 and temperature is 25 degrees Celsius. So for this, what should we do? We weigh a 3.814 gram of borax and It is dissolved in either deionized water or distilled water and dilute to a 1 liter. Okay, now we take a 1 liter of conical flask or a beaker and put 250 ml of distilled water or deionized water, and then we add 3.814 gram of borax and mix it. After mixing it properly, we add remaining distilled water up to a 1 liter, and here we dilute it with the 1 liter. Now, fresh borax may be used or it may be recrystallized, but it should not be over dry. Okay, for the preparation of dilution water, freshly boil and cool deionized distilled water to expel our carbon dioxide. Specific conductance of dilution water should be less than 2 micro S at 25 degrees Celsius and the pH value at the range of 5.6 to 6.0 for the preparation of all the standard solution. So this is how we prepare the first buffer, that is your borax buffer. The next buffer is your phosphate buffer. Okay, so phosphate buffer is 1 is to 1 solution whose pH will be 6.865 and the temperature range is again 25 degrees Celsius. Okay, so for this again we take a beaker, and in beaker we prepare, first of all we prepare a 0.025 molar of potassium dihydrogen phosphate and 0.25 molar of disodium hydrogen phosphate. Dry potassium dihydrogen phosphate and sodium hydrogen phosphate in an oven at 130 degrees Celsius for 2 hours and cool in a desiccator. Okay, so for the preparation of 1 is to 1 1 is to 1 solution, pH range 6.865 solution, we have to take a 2 solution. One we required a 2 solution. First one is your potassium dihydrogen whose molarity will be 0.025 molar, and the second one is your disodium hydrogen phosphate again whose molarity will be 0.025 molar. Now first of all we take potassium dihydrogen phosphate and potassium hydrogen phosphate and dry it at 130 degrees Celsius for 2 hours and then we cool it into a desiccator. Now we dissolve 3.388 gram of potassium dihydrogen. Again we take a 200 ml of distilled water and then we put a 3.388 gram of this potassium dihydrogen phosphate. Potassium dihydrogen phosphate, and the second one is your sodium hydrogen phosphate, and the amount will be 3.533 gram. But before it we have to dry both of this at 130 degrees Celsius for 2 hours. Okay, then after that when it is completely dissolved we dilute it with a 1 liter of deionized water or a distilled water. Now the next is your tartrate buffer. Tartrate buffer, we prepare a solution of 0.03 molar solution whose pH will be a 3.56 and 25 degree Celsius temperature. For this we require a saturated solution of potassium hydrogen tartrate in a deionized or a distilled water. Next is your phthalate buffer, 0.05 molar of solution, pH 4.008 at 25 degrees Celsius temperature. Now for this we required a potassium dihydrogen phthalate 10.12 gram, and it is dilute with a 1 liter of deionized water or a distilled water. Next is your tetraoxalate buffer. It should be prepared for a 0.05 molar solution, and pH range is 1.68 and 25 degrees Celsius temperature. Okay, dissolve. Again, what we have to do, we take a beaker and put 500 ml distilled water, and then we add a 12.61 gram of potassium tetraoxalate, and when it is completely dissolved, then the remaining 500 ml deionized water will be added. Now the next is calcium hydroxide buffer. Okay, it should be prepared for 0.023 molar solution. pH will be 12.45 and temperature is same 25 degrees Celsius. Ignite well-washed calcium carbonate of low alkali grade platinum dish at 1000 degrees Celsius for 1 hour. Now hydrate the cool calcium oxide by using a deionized water slowly with stirring and heat to boiling. Now filter the cool suspension and then collect the solid calcium hydroxide on a glass filter of medium porosity. After that, we dry the collected calcium hydroxide inside the oven at 110 degrees Celsius and cool it pulverized to uniformly fine granule. Now, after that, vigorously shake the excess amount of this product in a polyethylene bottle with a distilled or demineralized water. Then allow the gross excess so that it will settle the filter by a suction through a treated glass funnel. Now keep the second stopper bottle to prevent the increase of the carbon dioxide. So the pH value of buffer at different uh, at a different temperature. Okay, so the first one, the first is, this is your potassium tetroxide, potassium hydrogen tartrate, potassium hydrogen ferrate, potassium and phosphate, disodium hydrogen phosphate, sodium borate decahydrate, calcium hydroxide saturated at 0 degrees Celsius. It will be a 1.647. Potassium, no data. Potassium hydrogen and phosphate 4.1. So this is a table for the pH value of buffer at different temperature. Again, this is same. Now sample handling and preservation. So sample should be analyzed as soon as possible because it preferably in the field at the time of the sampling. High purity water and water not at equilibrium with the atmosphere are subject to changes when exposed to the atmosphere. Therefore, the sample container should be filled completely and kept sealed prior to the analysis. Now procedure, we have to follow the instruction from the manufacturer for the operation of the pH meter. After a required warm-up period, sterilize the instrument with the buffer solution of the pH near that of the sample and check the electrode against at least one additional buffer of different pH. That is called a calibration part that I already told you. So what we have to do, first of all, we calibrate it, and simply calibration, for a calibration we take two different buffer solution, and we already know the pH of that buffer solution. After calibration part, what we have to do, we simply put the electrode and dip inside the sample and measure the value and also follow the manufacturer instruction. Calculation part, report the pH to the nearest coefficient or 0.01 unit if the instrument read up to 2 decimal places, and temperatures to the nearest degree Celsius. So this is all about the electrometric method. I hope you will understand. But if you have any query related to this topic, you can ask me in a comment box, or for a further detail, you can follow the ITLS Academy on different platforms like Instagram, Facebook, Twitter, YouTube, WhatsApp, LinkedIn, and subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. Or for any query, you can ask your query to the helpline number that are already mentioned in your slide, that is 7080833450, and visit our website www.itlsacademy for any for further detail. Thank you for watching. Please like, share, and subscribe our channel.